Welcome viewers, this is part 7, that is final part in design of warehouse structures. In this we are going to do foundation design using robot structural analysis with the Eurocode. These are the various parameters which we are going to feed into that robot structural analysis, and these are the steps, 7 steps which we are going to follow. First one is the loads to foundations. So these loads are from the structure. This is generally taken care by the robot structural analysis, as we are already done the model and the load applications into the robot structural analysis. Now we are going to just select and feed into the foundations. These are the loads structures to be considered. Next one is the foundation dimensions. In next step we are going to assume some foundation sizes to check whether the sizes are okay with the foundation loads and the foundation soil bearing capacity. And then third one is the foundation parameters we need to define. Fourth and fifth are the concrete and the steel, reinforcement steel definitions we are going to provide into the robot structural foundation calculations. Next one is the soil parameters we need to provide. And finally, after applying all these 6 steps, we are going to click the calculation or the run analysis, so that the robot structural will provide the results for the foundations. Now let me look into more detail about those.
Design is very simple in robot structural analysis, especially that shallow foundations. So first of all, we need to select the node number. So we can start our foundation design by selecting the node one by one. So what is our plan is that all the door column can be fixed with on the floor slab, and only the main column which are to be connected on the foundations with the base plate and anchor bolt. So we are selecting node number 1 and go to design provided reinforcement of RC elements. So here you can see that robot structural will consider all the forces which we have considered during the structural modeling and the structural load applications. So all the loads and the load category, this will consider and taken care about by default, while we are doing by selecting the node number and going to clicking the design and selecting the provided reinforcement options. So now we need to click this OK, so that all the force value will be taken care by robot structural analysis by default. We have fixed our foundation level at 0, so this foundation which we have selected as will be added here. So double click this, you can able to see the foundation sizes here. So for the first foundations we can give this value 2 by 2 1 meter, and these parameters we can give it as 0.6, there is no issues, and here we can give 0.5 meter. So these all the parameter we can fixed, and no eccentricity, ex and ey should be 0, and this also fixed. And this column dimensions we can give it as 0.7, which should be greater than the column which we have designed is 533, that steel column. It should be greater than that, at least 200 mm. So we have assumed this and click apply, so that the size will be changed accordingly here. And go to the pier. So we are going to apply with the bolded connections like anchor bolt connections, so that anchor bolt spacing we need to define here. We can assume 300 by 300, or during our connection design we have considered 350, so that we can consider and click apply and go to this optimizations. So in optimizations we can say that it should be designed as a square footing and click OK. So these are the foundation size parameters we need to define, and after that click this 1 2 3 icon, which is a storage parameter. So here we need to give that environmental of concrete, so we can assign this XC2. So these detailed definitions we can able to find out in EN 1992 part 1. And this admissible cracking we need to define if we are going to do for water retaining structures. So generally this will have water retaining or oil retaining structures, it should be 0.2 mm, and in case of it is having like normal foundations we can have it as a 0.3, because these failures will not have much impact, this is a small crack and all. So we can have this allowable crack as 0.3, which we no need to change as per standard robot structural input. So this, if you want to, you can change this structural class. So this is structural class also defined in EN 1992 according to that, and according to the customer specifications we need to assign this. So remaining portions we no need to worry about this, and we can save this as some new name called demo, because we need to do lot of foundations. So even that we are having that 14 numbers of column, main column, and also 3 number of wind post. If we are going to do all the foundations, then we need to have a standard template for this kind of parameters. So we can add it as a demo and click OK. Next, go to that third icon, which is showing the calculation options. So in that we need to define the punching shear requirement safety factors is 1, and also this cover, if we want to give any different than 50 mm, we need to give it, and this we can select as a small risk brittle failure, also need to check according to this calculation requirement. And now go to this concrete. So British standard we are going to follow, and we can choose the concrete number, concrete strength or grade. So here we need to edit the concrete value, so it should be 32, but in this case it is showing we are unable to edit. So here we can also give the size of the concrete. So in order to edit this, we need to define the parameter first. So for that we need to go to tools, go to the tools and click the job preference. So for that we need to select the materials from this list. So we have selected British. If you don't want British, we can select the Eurocode and give the concrete strength value. So if you want to give any modifications, you need to click this and go to this concrete and click this for C. We are going to select this C30 for 37s. So this value we need to define, at least mainly the concrete characteristic strength we need to define here. So once after defining that, we can click this OK and click save parameters and click OK. So now if you want to check this by clicking this icon, and you can see here this C20 had changed, updated, and we need to select this, and here the Eurocode is displayed. Now the characteristic strength is added here. So this also we can save it as a demo for further foundation design. And next we need to define the reinforcement. So here also we can select this any one type B or C, and according to that 6 mm which is not in use, we can deselect this, and we are not interested in higher diameter, so we can select accordingly and go to the transverse reinforcement. So here also we need to select this BC, so that this H can be arrived, and here also that 6 mm is not required, and even the transverse reinforcement we don't have any interest more than 10 mm of diameter. So additional reinforcement if required we can also select this, but in this case is not applicable. If we want we can add it those also. So this is what we need to assign the reinforcement type and the concrete strength in this. So you can again click save as and save it and click OK. Now the third parameter is a reinforcement pattern. So reinforcement pattern for column, we can generally assume this one, first type, and here also we can apply as a demo. And double bars, so these details are not required for this, and you can click this. So you can see here these values are changing demo. Next one is this one is a dimension parameters, so that we are already having here, and this one is a load parameters. So this load parameters we already selected. So if you want to check this, you can click this, so that all the loads which we have developed in the structural model is added here. And the next is soil definitions we need to provide. So click this. So we need to assign the depth of the foundation and the soil parameters which is required for the foundation design. So here we are going to assume this water table as 0.85. Click apply, and our soil will be well graded gravels, so that is okay for us. We can provide the same. And again this our foundation will be 0.2 meter above the ground level, so we need to type it here and apply. So you can able to see here this picture, this is moving little bit above the finished ground level. So these are our foundation depth, that is soil parameters, where the foundation is going below the soil. So this also we can save it as a new name demo, which we can apply for other foundation also. So next, coming to that next parameters, so we can click apply and close. So next parameter is geotechnical options. So in the geotechnical options we are going to give the safety factors for rotation, that is overturning, sliding, and average settlement. So settlement criteria we all know that for the shallow footing we can go up to 50 mm, and for combined footing we need to check that differential settlement which is around 25 mm. So this 50 mm is allowable as per the European standard EN 1992 for shallow foundations, single shallow foundations. So contact surface check also we need to consider while doing the calculation. So that is why we are selecting this. Because of the bearing pressure, negative bearing pressure, there will be some loss of contact. So there is also some limitations according to the EN 1992. The loss of contact should not beyond 10%. So that also check also can be done as per this code norms. And this also we can save it as a new name as a demo. Even as we are not going to change any value, we can also have it the same as standard by default. So click this. Now we can save it, and now these parameters we have assigned all the parameters, and the forces also we have applied. We need to click this, just this start calculations, and click this calculations. Now the calculation is run, and you can see here this green color indications, it is showing the results are available. And also you can see here a green color tick in this foundation name. It means the foundation had done, and this foundation size is passed. In order to optimize, what we can do is we can deselect this and again click apply and click run, calculate. So we need to do some optimizations. Even though the 2 meter is okay for us, we need to run again by selecting this untick. So now you can see it is showing only 1.5 meters. So it is telling that 1.5 meters is sufficient. So this is an optimized solution. So we can also see the other result like reinforcement. So this is reinforcement view which we can see it. So here you can see that reinforcement which is mentioned as H12. So numbers is 24 numbers. So accordingly we can calculate the spacing also based upon the foundation sizes and the lateral. So while selecting this entire row, it will show where this reinforcement is applicable. However, we are missing the concrete reinforcement. So for that we need to change. Pedestal reinforcement is missing here. So for that we need to change this pier reinforcement. So click apply and again run this. So now you can see this reinforcement for pedestal also. So this is what we need to do it for reinforcement arrangement. The middle part we need to do. Similarly, like we can also try for this third icon and click this calculation to run again. So you can also check whether this pattern is sufficient for us or this is more common standard. So likewise this foundation should be done. So accordingly the sizes also we have defined. So now we need to do for another foundations. We can save it and we can go to that structural model. Now we can select the node number 2. So which you can see here, node number 2 is here. Again go to the design and provide a reinforcement parameter. So here again it will ask the same question, whether the force in the structure can be considered, and accordingly we need to select this and click OK. So only the simple cases will be taken from the structure, and according to the foundation load combinations as per EN 1997, this load combination will be done in the robot structural by default. So again here same thing, for in order to maintain the uniformity of the foundations we can have the same this H1 and H2. H1 is nothing but the raft thickness and the H2 is pedestal above the raft thickness, so that we need to define here, and the eccentricity we can give 0 0, and similar like pedestal size in plan also we need to give like 0.77, and here again the same things we need to consider as per the foundation one, and in optimization also we can consider the square and apply this. So here simply we need to select demo here in all the, so likewise in all the area we need to select the demo. We no need to go to this right hand side as we have defined, because that is structural parameter for entire building foundation. Wherever the foundation is going to located, that entire area will be the same, more common, and everything that are including all the foundation parameters is the same for all the foundations. Only the sizes and the loads. So sizes and loads we need to define in the separate manner which we have just seen for the foundation 2, and the remaining things these parameters are remain common. So just selecting this demo itself we can assign all the remaining parameters except the size and the loads. So no need to go to this right hand icon again and again for the total 14 plus 3 number of foundations of this demo warehouse. Now click this calculate, and the calculator will be done accordingly, and we can able to get the foundation with optimized size in the robot. So this foundation we can go with 1.9 meter. Now we can again save it and go for another foundation 3. So one good thing here is we can also view the foundation model. So if you click this no view options, so which are the foundations we have designed, that foundation we can able to see it in here itself in the model, so that we can avoid doing the redesign once again by selecting the nodes. So this is one good benefit in robot structural, so that we can avoid our time in doing the redesign of the same foundations. Now select the node number 3. So similar like we need to do for all the 14 plus 3 number of foundations including the wind post. So the same pattern like the force we have directly extracted from that structure model. Again this one more tips is there, while selecting the node and coming to the design and provided reinforcement option, this previous foundation and the selected earlier foundation will select by robot by default. During this time we can directly apply, click this apply means, then the foundation size parameters also copied from 2 to 3, that is the previous foundation to the this foundation. So you can see here, so even that foundation size parameter also we no need to change now. Only thing, the load already taken care from the structural model, so only thing we need to select this to demo. So after selecting this to our general parameters demo and click calculation, so this will automatically again do the calculation according to the force for this node number 3. This foundation will get optimized, and now it is seem to be 1.7 meters is sufficient. So now again after saving this file, and we need to go to do with the next foundation, that is in the node number 4. So you can see here the node number 3 also designed with the foundation, and click the node number 4 and again click this design provided reinforcement of RC elements. So again this will ask for whether the force to be considered according to the structure, and do you want to any modifications, you can do it. Click OK, and this will run with that. And again you can see that the previous foundation sizes and 3 and 4 also selected, and simply click this apply, so that the size of the 3 and other parameters like which we have defined here, right, in the like a peer optimization, every option can be selected from the previous one. So we no need to do that, only simply select this general parameters which we have selected already. After selecting all the general parameters, click calculations. So this is what about doing the foundation for this. So with this we can end this video. Look description for more related videos and subscribe to this channel for more updates. Thank you.